Hey guys, this video is going to be about inverse trig functions and focusing on just sine, cosine, and tangent for today. And the concept, we're going to relate the concept of inverse functions to our trig functions. So the first thing I want to focus on, we're going to kind of take each trig function separately, talk about it a little bit, discuss what the domain and range looks like. But I'm going to go ahead and start with the sine function. So I'm going to go ahead and graph the sine function. And what I see here is that that domain is going to go from negative infinity to infinity. And the range is bounded, where it goes from -1 to 1. So with that, if I would draw the inverse function, now keep in mind, inverse function is where you are, reflecting your function over that line y equals x. And what happens is that we're going to get, I'll just call this g of x. Actually, no, you know what? I'm going to use the proper notation here. The inverse function is that f to the -1. We call that inverse of f. So the inverse of f is sine -1x. All right, so that -1 simply indicates that it is an inverse. So our x value represents our angle, and the f of x represents our trig value, and that goes for all of these functions. So I want to show you what the inverse sine looks like. Okay, so I know this is the sine function is a function because it passes that vertical line test. However, it does not pass the horizontal line test. So therefore, since it does not pass the horizontal line test, then it's not a one-to-one function. So in order for that arc sine, that inverse sine, to be a function, we have to restrict the domain. Okay, so we're going to look at just the part that would make it a function. Okay, so let me go to this y equals, I'll clear this out, and I want to show you what that inverse sine looks like. Notice, it's just a little segment of it. Okay, well, what segment is it? It is the segment from the -1 to 1. Okay, here's why. So in order to, let me graph this sine function again so you can see it. In order to restrict this domain for the sine function, I need to just look at, I'll give it a little sketch here, because we know those zeros are at 0, pi, and 2 pi. It's bounded at 1 and -1. That is one cycle, one revolution. However, it does go on infinitely in both directions. Here's the other one. So here's what I know, is that I have to, in order to get this inverse sine, I have to restrict the domain of the sine function to just this little section right there. Okay? So this domain is, I'm going to just call it, I'll put it in quotes here, is restricted from -pi/2 to pi/2 in order for it to be a one-to-one function. So if I am looking at the sine function here that I drew, it passes the vertical line test within that yellow little block, and it also passes the horizontal line test, so therefore it's going to be a one-to-one function. So my domain is restricted, that's why I put it in quotation marks, I'll redo that a little bit here, make it look a little easier to read. I put that in quotation marks just because it is our restricted domain in order to make it a one-to-one function. So when I'm looking at this arc sine, and I'm talking about the inverse, well, what we have learned in the past is that the domain, when you switch your x and your y values and you do that reflection over that line y equals x, the domain becomes the range and the range becomes the domain. So what you will notice is that the domain is going to go from -1 to 1, and the range is going to go from -π/2 to π/2. So in other words, the trig value is going to become the x value, and the angle measure is going to become your output, your y value. Okay? So let's take a look at the cosine function. So the cosine function, if I graph this, has maximums at 1 and minimums at -1. And so if I go, say, just 0 to 2 pi, and maybe I should mark that in the above graph as well, because that would be -2 pi to 2 pi that I've shown. I'm going to go ahead and do the same thing with my cosine function. I'm going to draw the cosine function that we have learned about. And I'm also going to sketch it in that negative direction. Okay, so -2 pi. All right, and it's got its maximums. At -pi, it has a minimum. At -π/2 is 0. -3π/2 is 0. Okay, so here is my cosine function. All right, let me give that to you here on the calculator as well. Just a better picture, I should say. So this is an even function, and what we have to do is just kind of focus on that vertical line test and the horizontal line test. Because what we're trying to create is a situation where the relation, the sine is a function, and the inverse of that sine is a function. So the cosine, well, if I pass as the vertical line test, yes. So the cosine is a function. However, when we do the horizontal line test, it is not a function. So we have to restrict the domain. So let's go ahead and write that domain of the cosine function, and that's -∞ to infinity. And that range is going to be from including -1 to including 1. So we have to restrict the domain, okay, of where that's going to be a function. And we do that from, let me get a little highlighter here, 0 to pi. Okay, so within this yellow block here, that is going to be what we're going to look at. So we have restricted the domain from 0 to pi. Okay, so that would indicate that the inverse of our cosine function is also going to be a restriction, based on that restricted domain. So let me go to y equals, and I'll just kind of show you what that graph looks like. All right, notice it goes from -1 to 1, and it's going to go from, range is going to go from -π/2 to π/2. So just like the sine function, that the domain for the cosine is going to be -1 to 1 because it is the range of our cosine function. So the inverse cosine domain is the same as the range of our cosine. And that means that the domain of the cosine will have the same range. And just keep in mind that it's based on this restricted domain, and it goes from 0 to pi. Okay? So whenever you're doing the inverse trig functions, your domains become your ranges become your domains. Okay? Now, I've got the unit circle here to the left. And I want to talk about this inverse sign. And so if the inverse sign and the domain goes from -1 to 1, and then that means the output is going to be from -pi/2 to pi/2. So it's going to function, let me see if I can get a smaller here. It's going to function and just look at, I don't want to draw it there. Let me redraw that. It's going to be restricted to these two quadrants, quadrants 1 and quadrant 4, okay? And notice that sign, the domain goes from -1 to 1, all right, for our domain, and then the range is going to be the -pi/2 to pi/2. So we're focused and we're restricted to quadrants 1 and 4 when we're dealing with the inverse sign. So inverse cosine, well, what does that restricted to? Well, if the output goes from 0 to pi, it's going to be from, let me see if I can do that a little better, my gracious. From 0 to pi, and it's restricted to quadrants 1 and quadrant 2. All right? And for our values, all right, for our cosine values, all right? And it's going to include these 2 points here at the end, okay, of those quadrantal angles. So now we've got one left to talk about, and that is our tangent function. So our tangent function is normally, if I draw this, it has an asymptote at -pi/2 and an asymptote at pi/2. Okay, so -pi/2, pi/2. See if I can at least write this a little better so you can see it. And it has 0, and tangent is an increasing function. Okay. So the domain for our tangent function is not including -pi/2 to not including pi/2, because that is where our asymptotes are. But the range is -∞ to infinity. Okay. If we're talking about the inverse tangent, that arctangent, okay, so I'll go ahead here and draw the tangent of x, maybe if I clear that out, tangent of x, and graph that. Notice that's multiple periods, okay? I'm just drawing the one that goes from -pi/2 to pi/2, or -1.57 to 1.57, okay? Now, if I want to draw the inverse tangent, actually I need to enter a variable. There we go. That is your inverse tangent. Notice what happens, that the domain goes from -∞ to infinity, and the range is going to go from -pi/2 to pi/2, because when we do that reflection over that line y = x, the x's and the y's switch, which means our domain is going to become our range, and our range becomes our domain. So here I would have asymptotes at pi over 2 and negative pi over 2. Right? And the inverse tangent here is going to be an increasing function. All right? So talking about where we're restricted on the unit circle, notice it does not include that negative pi over 2 and pi over 2. Okay? And it is restricted to these two quadrants, 1 and 4, for my output. Right? So not including the negative pi over 2 or pi over 2. All right? So take a look. I'm going to scroll up. Notice that the sine function includes negative pi over 2 to pi over 2, but it's also using the same coordinates, okay? Or same quadrants, sorry. Quadrants 1 and 2. So here is negative pi over 2. Here is pi over 2. For the cosine function, it goes from 0 to pi. And then for the tangent function, your output's going to be negative pi over 2 to pi over 2, but not including those. All right? So to sum up, you've got a sine function, you have an inverse sine function. In order to make it a one-to-one function, you have to restrict your domains. And then to find the domain and the ranges of our arc sine, the domain of the sine becomes the range of the arc sine, and the range of the sine becomes the domain of the arc sine. They kind of like switch spots, if you will. All right? And then the cosine function and the arc cosine function, in order for them to be a one-to-one function, it has to be restricted on that domain. Okay, so it goes from 0 to pi for our cosine function, which means the range of our arc cosine will be 0 to pi, and then the range and the domain also switch. So the tangent function here, notice that doesn't have to have a restricted domain because this passes both the vertical line test and the horizontal line test. Right? So therefore, we could go ahead and go straight to graphing that inverse tangent or that arc tangent, however you want to say. All right, so let's fill in this little worksheet right here. So what you'll notice is that the domain for the sine becomes the range for the arc sine. And the range becomes the domain, okay, when you do the inverse. So if you're looking at cosine, the domain is 0 pi, and that makes the range, or the range of that function, I don't know why it's not copying here, makes the range of that function 0 to pi. So if the range is from negative 1 to 1, that would indicate the domain is from negative 1 to 1 of my arc cosine. Talking about tangent, notice the does not have brackets around that domain, and that's because you have asymptotes there. So if your domain is from negative pi over 2 to pi over 2, your range is going to be negative pi over 2 to pi over 2. Notice not including those. And then if the range is negative infinity to infinity, that means your domain is going to be negative infinity to infinity. Okay. Now, I think I made a mistake in my, my previous statements about the tangent not being restricted. We do have to restrict that from negative pi over 2 to pi over 2 in order for the arc tangent to also be a function. Okay, so sorry about that. I'd like to just work some problems here. And for this, we're going to, I've got the unit circle here. See if I can make it any bigger, that unit circle. Well, it doesn't look like it's going to work out here for me to make that a little bit bigger. Hopefully you got a unit circle maybe in front of you is helpful. So we're going to try, I wonder if I can maybe move that, slide it down, make it bigger. There we go. See if that helps at all. Nope, that did not help at all. I'll make it a little smaller. Okay, maybe that's a little bit better. So taking a look at some problems here, and you have to evaluate these. When you're looking at the arc sine, keep in mind the arc sine is where you are looking at quadrants 1 and 4. Okay, so if the arc sine is a half, that means I'm restricted within quadrants 1 and 4, and I am looking for the angle measure, because the angle measure is our output. Which angle measure has a sine of a half? That is in quadrants 1 or 4. Okay, so looking at the y value, where is it a half? Well, it's a half at pi over 6. So the arc sine of a half is at pi over 6. Okay. So let's take a look at this next problem where it says the arc sine of negative square root of 3 over 2. Well, arc sine is restricted to quadrants 1 and 4. Where is the y value? What coordinate has a y value of negative square root of 3 over 2? Well, negative square root of 3 over 2, the y value, is right here. Okay. So, well, you've got to, evaluate it. It's going to be right here. But notice that matches up with 5 pi over 3. Well, that's kind of a problem. So when I'm dealing with unit circle here, and I'm going from negative pi over 2 to pi over 2, and here's 0, I know that this is pi over 6, which means if I go in the clockwise direction, that's a negative pi over 6. And here would be a pi over 4. If I go in the negative direction, it's a negative pi over 4. And then this would be pi over 3, and in the negative direction is a negative pi over 3. So this spot right here matches up with a negative pi over 3. So the arc sine, the inverse sine of a negative square root of 3 over 2 is equal to negative pi over 3. Okay, let's see, what's the arc sine of 2? So I'm still restricted to the first and fourth quadrants, and I need to know where is the y value 2. Well, you'll notice from negative pi over 2 to pi over 2, there is no y value of 2 because you have a unit circle. Unit circle, the radius is 1. So this doesn't exist. Okay, that arc sine of 2 does not exist. For number 4, if you have the arc sine of pi over 2, well, let's see. What is pi over 2? That's 1.57. So that is the arc sine of 1.57. Again, it doesn't exist. Why? Well, because I have a unit circle of 1. So I'm not going to have a y value that's greater than 1. Number 5. Number 5 is kind of got a couple things here with it. And keep in mind you got to start with your parentheses here. The sine of pi over 6. Well, if I go to pi over 6, the sine of that is a half. So then if I say what's the arc sine of a half, I'm restricted to quadrants 1 and 4. I'm looking at where the y value is a half. It's equal to pi over 6. So notice, basically, this arc sine and the sine, since they're inverse of each other, they kind of cancel each other out. So that's going to be pi over 6. Take a look, though, at number 6. So keeping that same idea, arc sine and sine would cancel each other out, but that's 7 pi over 6. Well, here's what I know. With an arc sine, I'm restricted to quadrants 1 and 4, and nowhere in quadrants 1 and 4, 1 and 4, do I have a 7 pi over 6. I have a negative, right? Pi over 2 to pi over 2. So we have to look. So go to 7 pi over 6. 7 pi over 6 is, I'll kind of bubble that in for you. 7 pi over 6, the sign of that is negative a half. So now I'm looking at what is the arc sign of negative a half. All right, so now I'm done with the bubble. I'm at arc sign of negative a half. I'm focused on quadrants 1 and 4. I'm looking where in quadrants 1 and 4 is the y value negative a half. Well, the y value is negative, well, in quadrant 4. Where is it negative a half? Right here. That's 11 pi over 6. 11 pi over 6 goes to negative pi over 6. So notice you're using the values that I've written here at the top from negative pi over 2 to pi over 2. All right, so that takes care of some of our arc sign. We're going to do the same idea, but we are going to use cosine. Okay. So if I have the cosine and it's restricted to quadrants 1 and 2, it goes from 0 to pi. I can go ahead and use the values that are given, okay? The radians of that unit circle. I can go ahead and use those. So again, I'm in quadrants 1 and 2. So the cosine, the arc cosine of negative square root of 2 over 2. Arc cosine restricted to quadrants 1 and 2. Where is the cosine negative? Well, it's negative in quadrant 2. Where in quadrant 2? Is the x value a negative square root of 2 over 2? Well, that's at 3 pi over 4. Okay. I'm going to go ahead and do number 9 as well, since we're on arc cosine. So taking a look, I'm going to focus on this parenthesis. What is the cosine at 5 pi over 3? Well, I'm going to bubble in 5 pi over 3. And its cosine is equal to 1/2. So I need to know what's the arc cosine of a half. So arc cosine, well, I don't need the bubble anymore, so I'll get rid of that. Arc cosine restricted to quadrants 1 and 2. Where's the cosine positive? Quadrant 1. Where in quadrant 1 is the x value a half at pi over 3? Okay. So let's talk tangent. All right, so for tangent, we are focused on quadrants 1 and 4. However, remember that at negative pi over 2, the tangent's undefined, and at pi over 2, the tangent's undefined. Okay, so let me get this unit circle ready as well. And we're focused on here quadrants 1 and 4. All right, so taking a look, the tangent is negative 1. All right, well, think about what tangent is. The tangent is the sine over the cosine, correct? So where is the tangent? Negative 1. Well, the tangent is negative in quadrant 4. Where in quadrant 4? Well, when you take the sine divided by the cosine, that's going to be right here at negative pi over 4. Okay. Looking at number 10, I have to do the tangent of wow, that's terrible. Let's try again. A little better. All right, so the tangent is 7 pi over 6. I'm going to go to 7 pi over 6. And I'm going to say, well, what's the tangent? Well, the tangent is going to be sine over cosine. So the tangent of 7 pi over 6 is equal to the sine, negative a half, over the cosine, negative square root of 3 over 2. Well, that is the same as 1 over square root of 3. So I'm looking at the arctangent of 1 over square root of 3. Well, arctangent is going to happen, and it's being positive in quadrant 1. So basically, you're looking for that same x and y value, but in quadrant 1. So I'm going to slide over here, and that's going to be at pi over 6. So the arctangent of 1 over square root of 3 is at pi over 6. Okay. Hope this video helps you with learning about inverse trig functions.